Okay, so welcome back to MEFB 2013. So in the last class, if you remember, we were discussing about grinding and abrasive process. So what is grinding and abrasive process? A quick recollection, yeah? Grinding is the last or almost the second last process in any manufacturing procedure, meaning that if your product undergoes manufacturing, okay, be it a sand casting, a die casting, metal cutting, hot chamber, cold chamber, hot working, cold working, press working procedure, the product will initially or finally undergo a grinding process. This is to ensure that the surface finish of your product is according to standards good, and finally you give it a finishing where the finishing processes will give it a good appearance, okay, for the product. So grinding process is divided to three categories: the cylindrical grinding, internal grinding, and surface grinding. What is cylindrical grinding? If you remember, we spoke about it yesterday, is to grind cylindrical work pieces. So cylindrical grinding, you have center and centerless grinding. So a quick review, yeah. So if you remember, center grinding is the typical product where you have to clamp it. Okay, you clamp it and you're going to supply coolant. The workpiece rotates, and at the same time the grinding wheel rotates and remove materials. What's the shortcomings of this process? If you remember, I mentioned to you yesterday, centerless grinding setup time may be high. So meaning that it will take a long time for you to clamp the object, and if you do not clamp it well, what's going to happen? Object will, or your product would undergo vibration, and this will create deep scratches on the surface of the product. So center grinding is utmost it's very accurate, but it comes with a long setup time, which makes it very complicated, especially if you're dealing with mass production. Yeah. So if you look at centerless grinding, okay, so if you remember centerless grinding, I told you is much more a simpler version of grinding of a cylindrical object, where you have a regulating wheel, you have your grinding wheel, and your object is sitting on a work rest in the middle of both. So what does the regulating wheel do? Regulating wheel feeds your workpiece towards the grinding wheel, and all the three, the regulating wheel, the grinding wheel, and your workpiece rotates in the same direction. Okay, so why is this important? This is important so that the entire surface of your workpiece is grinded, and keep in mind, yeah, your workpiece is not going to move. It's going to rotate in its axis. What is moving is your machine. The regulating and grinding wheel is going to move back and forth to grind the entire surface of your workpiece. Okay, so what is the shortcoming of cylindrical grinding? Basically, like I mentioned to you yesterday, if your object has a flat surface, you cannot conduct cylindrical grinding, or if your object is made of several diameters, you definitely cannot conduct cylindrical grinding. So what is internal grinding? Internal grinding is to grind the inner surface of an object. So if your object is has got an inner diameter, yeah, okay, if your object is a cylindrical hollow object, the object or the product needs to be grinded internally as well. Therefore, you need to practice internal grinding. Internal grinding is the same concept. Now the grinding wheel is going to go inside the product and grind the inner surface of the product. So either the wheel has one movement and the work has two movement, meaning that your grinding wheel rotates, your workpiece also rotates in the same direction and move back and forth, so that the entire surface of the workpiece gets grinded. Or your second option is your grinding wheel rotates and moves back and forth, whereas your workpiece rotates in its same axis, okay, without moving back and forth. Yeah. And lastly, planetary grinding. The third one, surface grinding, is used for grinding of plane surfaces. So various variations of surface grinding: horizontal spindle plus reciprocating table, horizontal spindle plus rotating table, vertical spindle plus reciprocating table, vertical spindle plus rotating table. Okay, so these are surface grinding, yeah. So this is to grind a flat surface of an object. Like I mentioned to you, your object has to be flat. It can be a round plate. As long as the surface is flat, you can use the concept of surface grinding. Okay, so the variations in surface grinding, if you look at surface grinding, there are several variations, yeah. So you have a horizontal spindle. What do I mean by a horizontal spindle? This is your spindle, is in the horizontal position, and this is called a reciprocating table. What do I mean by a reciprocating table? The table has the ability to move back and forth, meaning that if your workpiece is large, or if your workpiece is long, sorry, correct my mistake, your workpiece is long, you can place it on this reciprocating table, and the grinding wheel will rotate and grind the surface. The grinding wheel is going to be rotating in its axis, and it's static. What is going to move is your workpiece will be placed on the reciprocating table. Your workpiece will move back and forth to grind the entire surface of the product. Then you have horizontal spindle plus rotating table, where the spindle is horizontal but is meant for a circular workpiece, yeah. Next one, vertical spindle reciprocating table. If your surface area is large, you want to use a vertical spindle. Okay, you have a vertical spindle reciprocating table where a table moves back and forth to grind the entire surface. And lastly, you have finishing operations. So these are real life examples of application of finishing operations in the industry, yeah. So what is an abrasive belt grinding? Abrasive belt grinding is like a pulley. Okay, if you are in the airport, and when you want to collect your luggages, yeah, you have you see the conveyor belt, right? So it has the same concept as conveyor belt, where you are going to place your workpiece on the surface. You're going to embed. This is like a belt. It's like a belt. You're going to embed the surface of the belt with abrasive particles, and you're going to place your object on it. So when you start, it's going to rotate and grind. You're going to clamp your object. The bottom surface of your object gets grinded. So when you're satisfied, you switch the position and you do the other sides. If there's 6 sides to the part, you do the 6 sides. Simultaneously, you can place 4 or 5 or many objects if your conveyor belt or your so-called abrasive belt is has got a large surface area. So at one go, you can grind several objects. Secondly, so what kind of grinding is this? Anybody? Okay, so this is a typical surface grinding process. Secondly, honing. What is honing? Honing is an abrasive operation to grind surface of a hole. So you have a cylindrical object, and if you need to grind the inner surface of that hole, how do you do it? You're going to have to embed abrasive stones into the mandrel. Okay, so this is the diagram, yeah. This is your mandrel. This is your mandrel. Okay, mandrel. And what does this mandrel do? It has got, or it holds abrasive stones, and these abrasive stones or this mandrel will rotate, and it'll move into the cylindrical workpiece and grind the inner surface of the cylindrical workpiece until completed. Number 3, what is lapping? Lapping is a process where after you have machined a workpiece, due to maybe your tool sharpness isn't there. So therefore, if you zoom into the workpiece, you will find that this is your workpiece, yeah. Upon machining, you have your workpiece. If you see that the upper surface of the workpiece has got uneven surface. So what happens to that uneven surface? What are you going to do? How are you going to level it? You can't go and use another machining procedure to level it. So what are you going to do? You're going to sprinkle abrasive powder. Now abrasive is not in the form of stone. It comes in the form of powder. Sprinkle abrasive powder on the surface, and you're going to use a leather and rub on the surface. So you're going to sprinkle abrasive particles. You're going to use a leather to rub against the surface. And what happens when you rub against the surface? You are going to smoothen the surface of your object, and you are smoothening it, but you're not going to change the dimension of that object. Number 4, super finishing. What is super finishing? Super finishing is the same as the previous processes. You're going to use an abrasive stones, but it's not a dimensional process. You use a super finishing when you already have your finished product with perfect surface finish, smooth. Unfortunately, what the problem is, because to over grinding, there will be burnt spots. So in order to remove these burnt spots, you may need to use abrasive stones. Lastly is mass media finishing. Mass media or barrel finishing is when you have tiny objects, screws, bolts, nuts, and these tiny objects cannot be clamped. Can you clamp a bolt or can you clamp a nut? Impossible, yeah? So how do you smoothen the surface of this kind of objects? You need to put it into a barrel full of particles and full of abrasive stones, and you let this barrel rotate. When this barrel rotates, the nut or bolt is going to rub against the surface of the product, and you are going to remove material. Yeah. So mass media finishing or barrel finishing is a good option. So therefore, I would like to stop or conclude my lecture for today. See you guys tomorrow in another video. I'll be on from 8 to 10 p.m. tonight. Please come online, comment on the YouTube, and go through the slides, and make sure you complete your assignment. Number 2 due date is tomorrow. Thank you.